Yeah, all right. Now we want to take a look at some of those problems, some of the problems that you had on today's worksheet, okay? And just go through, do a couple of them here and there, okay? Uh, in terms of a quick evaluation of these, all right? So again, here log 32 is asking to say what power must 2 be raised to produce 32? That's 5, okay? So it's 2 to what power is 32, okay? Down here, that's 3 to what power? 3 to the, what power? Y power is equal to 9 radical 3. Well, yeah, this is an exponential equation now, so you have to get the common base, right? So obviously 3 is the common base, so this is 3 to the y. This is 3 squared, and this is 3 to the 1/2, and we're multiplying those, so we add the exponents, and you get 3 to the 2.5, or 5/2 is equal to 3 to the y, so obviously y is equal to 5/2, okay? Same protocol you'll follow for these here, okay? Log, this is log base 10. You can sneak in the subscript if you want, but basically, you know, these are just asking 10 to what power is 1,000? Well, it's obviously 3. 10 to what power is 1,000th? Again, so if you wanted to make an equation out of that, you set it equal to y, say 10 to what power is 1 over 1,000? Well, 1 over 1,000 is, of course, 1 over 10 to the third, which is 10 to the negative 3. So 10 to the y equals 10 to the negative 3, so I guess y is equal to negative 3, right? Hey, the log of a negative can't happen. Remember what the graph of a log is? All logs have this graph, okay? X values, the domain, only positive, right? Can't take the log of a negative number, empty set. Same reason, okay? All right, let's go over here. Log 1, all right? So when you have a log graph, the x value of 1, then you know it's 0, all right? So that's 3 times 0, 0. These you work from the inside out. So number 9, you take the log of 10,000. So I know the log of 10,000 is 4. Then I'm asking, what is the log base 2 of 4? Well, 2 to what power is 4? So the answer is 2. It's not an equation, although you could make it one, but you don't need to. ln, log base e. So what is this asking? Well, this is asking, this, I don't know, is equal to something. Say, so then this is asking what? E to what power is e? Well, e to the first. So this should just collapse to 1. You'll find that this is a half. You'll find that this is 3/2. Should be no problem. Okay? The natural log of 1. Again, the natural log, the common log, all have this same basic graph. All right? Nothing. 0. Can't take the log of 0. Log is 0. Okay? What's the domain up here? Remember? Domain is simply the 0 to positive infinity. Not 0. That's where the asymptote is. So that's undefined there at 0. This is undefined, can't take the log of a negative. So that's it again. All right, here's some equations. You really got to convert these. Okay, again, these are log base 10. So that's 10. There's a subscript if you want to put it in there. So that says 10 to the negative 21st is equal to 1 over 1,000 to the negative 3x. Well, again, it's an exponential equation now. You have to put the common base. Well, common base is obviously base 10, and this is 10 to the 1,000. 1/1000th is 10 to the negative 3, so that makes that 10 to the negative 9, positive 9x, excuse me, which says 9x equals 21, and I'm not even going to solve that. You can, okay? Now, some people had a little squawked about some of these, but just have to be creative in the algebra here. What's it say here? This will translate into what? 10 squared equals what? Equals the cube root of 2x plus 10 to the, it's a cube root to the negative 2 power. So then this says 10 squared, or 100, but I'd leave it as 10 squared for now, is what? 2x plus 10 to the negative 2/3 power. All right? So you're working with, it's just an equation. You don't like this, you can simply raise both sides to the, well, let's say we raise both sides to the 3/2 power. So we raise both sides to the 3/2 power. Then, of course, we multiply exponents inside and out. So that gives us 2x plus 10 now to the negative first power. Okay? And this gives us what? 10 cubed, right? This just gives us 10 cubed, or 1,000. Okay? And so this is now actually 1 over 2x plus 10 is equal to 1,000. Or, you know, we can cross multiply and switch positions actually, and we get, or just take the reciprocal of both, however you want to look at it. And the reciprocal of both is 2x plus 10 equals 1/1000th. And you can solve that from there. That's not a big deal. All right. Same issue is going to go over here. Here's some people had some issues with the last couple here. Okay. Well, let's do number 6 here. This means what? Okay, this is log base e of 4x squared minus 1 is equal to 0. Convert it. 4x squared minus 1 equals e to the 0. Anything that is 0 is 1. So you got 4x squared minus 1 equals 1. You got what? 4x squared is equal to 2. So I guess you got x squared is equal to 1/2. So x is equal to the root of 1/2. Let's see if I did that correct. E to the 0 is 1, 4x squared minus 1 equals 1. Add 1 to both sides. Yeah, there we go. Okay? Come down here. The log of the log of the log. The log of the log of the log. Well, now, it looks awkward. Do a substitution. Make it look more user-friendly. That whole item there is going to be replaced. In other words, that whole item, the log of x is going to be, for the time being, substituted with u. So that my expression that's up here becomes the log of u equals 1. Well, you should easily see that's 10 to the 1 equals u. So u equals 10. Now I come back here. U equals 10. So now this is the log of x is equal to 10. All right, do another substitution. Let that log of x, the log of x, that inner expression equal, use a different variable, p. So now this says log of p equals 10. And that converts out to say p is equal to 10 to the 10. But now what is p? Okay, that's over here, right? So 10 to the 10, which is p, is equal to the log of x. So that means what? 10 to the 10 to the 10 is x. X is 10 to the 10 to the 10. A googolplex. There you go. Same protocol with these, let's just say. All right? One or the other. Okay? So substitution for the time being. U is equal to log 6 of log 3 of x. So the simplified expression becomes log of u equals 0, which translates out to u equal 10 to the 0, which of course says u equals 1. So now, come over here, this says the log 6 of the log 3 of x is equal to 1. 1, right? We're almost done, okay? Now, do another substitution. Let this guy, log 3 of x, be p. So log 3 of x is going to be, for the time being, substituted with p. So the expression now reads log 6 of p is equal to 1. Well, what's that imply? That means, okay, p is equal to 6 to the first, okay? All right? But now, I got to come back here and substitute my p-value, which says log 3 of x is equal to 6. So then x is going to equal 3 to the 6, which is what, 216 or 3 times, I don't know, whatever. No, 729, I believe that's it. 729. You can leave it at 3 to the 6. Doesn't make any difference. Okay, there you go. I hope you're good with the stuff now. All right, get ready for tomorrow's test. I posted up some stuff for you. Good luck, study well. It's the last test of the quarter aside from the exam, so do well on it.